Assalamualaikum. Okay, so for this video we are going to look at the tree diagram. Okay, so first we look at the purpose of the tree diagram. So actually we are going to consider the tree diagram if we want to display the outcomes of an experiment which consists of series of activities. Okay, and then actually in tree diagram we are going to list all the possibility, all the logical possibility that happen during the experiment. Okay, let's say we have one example. Okay, let's say you have a coin and then you toss the coin twice. Okay, indicates that you are performing the experiment 2 times. So the possible outcome, okay, by listed, we are going to look at the possible outcome will be H1 intersect H2, H1 intersect T2, T1 intersect H2, and then T1 intersect T2. Okay, so here actually how the outcome is come. Okay, actually you can refer on this one. Okay, when we are referring to tree diagram, actually we have to consider on the first toss. This is referring to the first toss. Okay, because you know that you are talking about you have 2 coin or you toss a coin twice. Okay, so on the first toss we obtain whether head or tail. So why we rename as 1? Because we are considering as a first toss. And then when you repeat the experiment 2 times, we also consider you obtain on the first toss is head, and then Y2 because we are representing this is referring to the second toss. And then given that H1 representing on the first toss, so indicates that when on the first toss you obtain H1, and then given that if you are performing the experiment 2 times or the second time you also obtain head. Okay, so here this is the way of writing for the tree diagram. We can refer that probability getting head given that the first toss is getting head. Okay, so if you want to find probability, we just simply apply the multiplicative rule where you have to consider the intersection between H1 and then H2. Okay, so we are going to obtain this probability. Alright, and then we can consider for all the possible outcome, which is representing the same probability because probability for head and tail are equal for every observation. Alright, okay, so next we go for the second example. Okay, let's say this one, you have a quality inspection program. You want to identify is there any reduction of the proportion, okay, of the defective parts. So the information given, we have 200 parts from old machine and then 250 from the new machine. So from the sample you found that the number of defective from the past, okay, from the old and then the new are 35 each. So draw tree diagram to represent the above data. Okay, so right now you know that the first information given is you have 200 parts from the old. This one is referring to old machine, and then this one referring to new machine. Okay, so how can you find this probability? You are going to take 200 over the total for the machine, which is 200. Okay, 200 plus 250. So that's why you obtain your number of sample is 450. So here 450. So we are going to find probability for new also. You get 250 over 450. Okay, the next information given is the number of defective for the old. So from the old, given that it came from the old machine, the number of defective is 35. So why over 200? Because your total old machine is 200. So if you are talking about defective from new machine, the probability will be 35 over 250 because the total probability for new machine is 250. Okay, so when you want to find the probability, you just simply apply the intersection, where here actually you are referring to 200 over 450 times 35 over 200. So you obtain 7 over 90, and then you can repeat the same procedure for all the probability. Okay, so that's all for tree diagram. Thank you. Assalamualaikum.